All right, so in our math workshop today, we're looking at number 1, 2, and 3. So for number 1, I need to add up these two problems. When I'm adding up these two numbers, all right, some of y'all can probably do it in your head. This is something you're going to hate about math class. You got to show your work. I got to see what we're adding because I can't see what's happening in your head, but I can see what's on your paper. So if I was going to write this on my paper to show my work for a super easy problem that won't take me long to write down, and I'm not going to complain about it, right? You'll see where I'm going with that? Y'all following that? Okay. All right, so how would I set this up? How would I line them up? Does it matter? Do I have to line them up? Can I just write them next to each other? How would I set this up to show my work? Sheldon?
So you write them like one on top of the other with the place value on the same spot.
Awesome, and I love that use of vocabulary that you might not have even realized you were using. He said you have to line up the place value. And what I want you to notice is, do y'all see how I'm spacing my numbers out? It helps me to tell where the place value is lined up. So underneath the 7, I want to make sure I put that first 2 because it's the 1s, 2, and 2. So I just want to show.
Middle School.
Just want to show they're lining up. I'm going to pause while we have announcements.
Pause for a moment of silence.
All right, so now that we're done with announcements, when I'm adding these up now, I can just add my 1s up. So 7 and 2 gives me 9. 4 and 2 gives me 6. 2 and 2 gives me 4. What about the other numbers? Now just bring them on down. So 3 comes down, 2 comes down because there's nothing to add to that. And what I'm always going to ask y'all to do is kind of put a box around your answer so we know that's the final thing that we should be looking at. All right? That way if you do mess this up and you need to change it, you can just mark it out, write it underneath, put a box around what it is you want checked. All right? So you're not trying to, if your eraser's not working or not working well, you can just mark it out. All right, number 2. Number 2. So again, I'm going to write my number on top. And guys, I really would encourage you, some of y'all have super neat handwriting. If you know that your handwriting isn't the neatest, spacing these out will help us out. So 289 going underneath that. And I got a little bit of space there to be able to write in my work. All right, so looking at this subtraction, it says 0 minus 9. Can I take 9 away from nothing? No, so what would I need to do here? Finley. Yeah, so I'm going to cross out the 3. Now, can I just borrow from the 3 and pass it all the way over to the very end? No, so we're going to borrow from 3, pass it over to the next 0, make that a 10. Then I can borrow from 10 to make the next 0 a 10. Borrow from 10, and that's where we get 10 at the end, and the other ones become 9. Something else I want to show you, so this is a neat trick. Guys, I learned this from a 6th grader. Like, I had never seen this before, and I thought it was really cool. So, 0, if I want to borrow from the number next to 0.
Students, please excuse this interruption. You may go ahead and post attendance.
Did it, because everyone was here. What number is next to 0? 300. Y'all see how I made that a 300 there? Okay, are you ready for this? This is really cool. This only works when you have a bunch of zeros, all right? If you don't have a bunch of zeros, it doesn't work. If I take 1 away from 300, what does it become? 299. I'm betting those are the numbers you had on top, isn't it? And the one that I took from 300 goes in front of that 0, making it 10. Right. I never knew that trick until a 6th grader taught me that, like 4 years ago. And I thought it was the coolest thing ever. All right, now again, the other option you can still do, I'm going to write it out here just to show, again, what we were doing. I can borrow from 3, making it a 2. This 0 becomes 10. Now I can borrow from 10, it becomes a 9, and this 0 becomes 10. Borrow from 10 again, it becomes 9, and now this one becomes a 10. All right. Most of y'all have been subtracting and borrowing for long enough. You know how that works, and you can probably do it quickly. The only thing that I see happen with my 6th graders, they get a little bit ahead of themselves, especially my advanced class trying to skip some steps, is they'll put 2, 9, 9, and they'll put a 9 here as well. All right. Remember, that last one should be a 10 because we're not having to borrow from it. Are y'all okay with that? If you want to use this technique, I'll kind of use it and show you what that looks like. If you prefer, you're like, I mastered subtraction a long time ago, Miss Sawyer, I want to keep doing it that way. You can keep doing it this way. I'm fine with that. All right, but I thought this was kind of a neat concept when I heard about it. All right, so 10 minus 9 is? 1. 9 minus 8 is? 9 minus 2 is? And then 2, there's nothing to take away, so I get 2. So we should get 2,711. All right? Have y'all ever seen that before where you borrow from 300? Some of y'all like yes, some of y'all like no. I had never seen. I thought it was cool. So y'all, it took me 30 years to see that. Okay, maybe not quite 30, but it took basically 30. We'll just say it took me 30 years to see that. All right. Last one that we're going to look at today is number 3. It says there are 24 students in each math class. How many total students are there if there are 4 math teachers? What operation am I going to use? What am I going to use here? Benny. Okay, so we can use multiplication. Why would I use multiplication? So why would I use multiplication, Nathan?
I was going to say, did y'all say multiplication or addition?
Benny said multiplication. Do you think addition? Okay, why do you think addition? Or why do you think multiplication? Okay, so you think multiplication too, Nathan. Why would we multiply?
Because it's easier than just 24 plus 24.
Okay, so it's easier doesn't give me a mathematical reason. That just gives me a Nathan thinks it's easier. So this is something we're going to work on in the 6th grade. So a lot of us are like, well, I know what to do, but telling us why, that's a little bit harder, isn't it? All right, so that's what we want to work on because this is some easy math. So let's work on kind of verbalizing the reasoning behind it. Kaya?
Because it's asking how many are in all classes total.
Okay, that's true. That is what it's asking, but does that tell me why we're using multiplication? No. Do you see? So we want to not repeat the question, but give a different reason. Finley, what do you think? Okay. So that tells me we use multiplication because we're doing times. That doesn't give me a reason that we're using times, which is still multiplying. So one of the reasons that I'm looking for, kind of here's your hint, okay? If we're multiplying, it means something is repeating. Do y'all agree with that? What's repeating here? The 24 students, and how many times is it repeating? 4. So we can say we're going to use multiplication. I like multiplication. I think that's a good option. Multiplication. Because 24 students repeats in 4 classes. Do you see how I did not restate the question there? I actually gave a reason. The reason is because it's repeating. All right, did anyone use addition? We could have used addition. What do you think would be a good reason for addition besides just adding's easy? Or because it says total? What are you doing when you're adding something? You're making it bigger? What else are you doing? If I'm adding something. So like you have paper in your binder. What if I give you more paper? What are you going to do with that paper? Put it in your binder. Add it together, right? You're going to put it together. So adding would mean that I'm putting something together. All right? So adding and putting it together. Subtracting, what do you think subtracting is? What would be a reason to subtract? Taking it away. That one's pretty easy. So take away, subtraction. Do we have to be taking something away or taking something off? What about division? Division's kind of tricky. Jesse?
Splitting something up.
Splitting something up. Perfect. So that's our reasons. If you're multiplying, it's because it's repeating. If you're adding it, because you're putting it together. If you're subtracting it, it's because you're taking it away. And Jesse was perfectly correct on dividing. You're dividing because you are splitting it up. Perfect. All right. Oh, show our work. We got to actually do that. So 24, I skipped out on the last part, times 4. So we're going to multiply the first numbers. 4 times 4 is 16. So we write the 6, carry the 1. 4 times 2 is 8 plus that 1, 9. All right, again, that multiplication should be some good review. So 96, and since this is a word problem, we're always going to write words with it. We're going to say 96 students. And you can see I'm trying to get back in the routine of school and writing stuff out. All right. Questions about Math Workshop? All right, so if you unclip that to write in it, that's awesome. Just make sure it goes back. Clip it into the Math Workshop section. Clip it into your Math Workshop section. All right, and then we need to get out a piece of paper. And you'll notice I put number 1 on here. This just helps them to stay in order. So, yeah, so it's going to be the first page. It's going to go in your notes section. So this, I like doing this because if you come in and we're on number 9 and the last number that you have in your notes was number 7, that means you've missed some papers and you need to get with Miss Sawyer or go check in the back folders to get papers. All right, so this is number 1. I'm going to give you a moment to get that set up. Where it says name, please don't write name. Please write your name. Where it says period, please don't write period. Please write first. Okay, so fill in the correct information for name and period. Your name and first period. All right, I'm going to pause this again while you get that filled out. Pause. Oh, there we go. All right, so for our vocabulary, the sum. What is the sum? What is that? Raise your hand if you can tell me. Leah. The answer to addition. So I'm going to say the result, because this is what you're going to see on a test in the future. The result, and a result is just an answer basically. The result of adding 2 or more, because you could add more than 2 terms. And you notice I didn't put numbers, did I? I used a special word called terms. All right? Because we are going to get to the point this year where we do a little bit of algebra. Algebra is that math that involves letters. And we're going to talk about what those letters mean. Letters are really just a fancy way of writing a number that could be anything. So like the letter X could be a 2. It could be a 347. All right, and we're going to talk about that more when we get there. If that's not making any sense to you, it is okay. All right, so a sum just means the result of adding 2 or more terms. And the reason I want to put the result is because it might not be like the final answer to the problem. It might just be a step in the process. All right, so the sum just means that we added something. All right, the difference means that we subtracted. So we'll say the result again. The result of subtracting 2 terms. Now for subtracting I did say 2 terms because when you subtract you can only do 2 things at once. You can't do a whole list of subtraction. You can only do 2 things at a time. And that doesn't change. No matter how high you get up in math, when you subtract, it's 2 at a time. Get your answer, then you can keep going. All right. Product. What is the product? That word should sound familiar as well. Lane? The result of multiplying. Very good. And here you can do 2 or more because when you multiply, you can do 2 at once or you can do more than that. So we're going to say the result of multiplying 2 or more, and we're going to say terms again here because again that gives us an option more than just numbers. So a term can be a number, it could also be a letter, it could be a symbol. All right, and we'll talk about that more this year, and you'll learn more about it even so next year. All right, a factor. Now this word you might remember, this one we might not. Does anyone know what a factor is? Alex? Not quite. That would be quotient. It would seem like we should do that next, all right? But I did kind of throw us for a loop. We're going to do quotients tomorrow. What is a factor, Noah? Owen?
It is a number in
It is the number in the
a multiplication problem.
multiplication problem. So it's not the answer, but it's the numbers being multiplied. So we're going to say the numbers being multiplied. The numbers being multiplied. All right. All right, I have a little star there because, again, y'all, I'm telling you, I learned so much from 6th graders. Y'all have some neat tricks that I had never heard about or didn't learn when I was y'all's age, like the subtracting from the zeros. Another thing to remember this, I had never heard this saying, factories make products. Do y'all agree with that statement? Factories, in real life, factories make products to sell, just like factors, the numbers that we multiply, make a product. So that's just kind of a way to remember how that works. Factories make products, just like factors make a product. Right? I thought that was cool. Someone told that to me last year, I think it was, and I was like, oh, I never thought about that. They're like, it's a good way to remember. I was like, that is a good way to remember that. Okay? All right. So for today, the main thing we're focusing on is being able to add. Raise your hand if you can add. Good job, guys. Awesome. All right, we're going to work on subtracting. Raise your hand if you can subtract. Good job, guys. And we're going to work on multiplying. Raise your hand if you can multiply. Good job. So today is going to be a super easy day. All right, so let's look at our first example. Now, guys, what's tricky about this example is all of the borrowing that's involved. So be careful with your borrowing. Remember, you do have to show your work because I'm a mean math teacher, and actually we all are. We all like to see your work, okay? Can't see what's in your head until you write it on your paper. So I'm going to let you try to set that one up, work it out, make sure you show your work, show what your numbers are changing to when you borrow, mark them out, all that fun stuff. Yeah, we're definitely going to have to get our homework done because I only got 2 problems we're doing in it today. Because we all know how to add, subtract, and multiply already. This is good stuff. Some of us, we might have to practice a little bit because it's been a while since we've probably done that. I'm assuming you didn't spend the whole summer adding, subtracting, and multiplying. Just a thought. No? Okay. Looks like a lot of us are finishing up or about halfway through there, just showing that work. How many people are having to try to remember what it means when you're showing your work? Getting that down on the paper instead of just doing stuff in your head. That's always a challenge for me sometimes is, oh, I can't just do it. All right, 7 minus 3. Do I have to have any work there? No, what's 7 minus 3? 4. Okay, there we go. We wrote down the work. We've got a 4, and we wrote it down. Ta-da. 2 minus 6. Can I do that? No, so I do have to borrow from the one next door. You can't do that trick that I was showing you earlier because, is that a 0? No, so we're just going to borrow from 1. And 1 becomes?
0.
That becomes a 0. And then my 2 becomes 12. So we wrote that up there. So now 12 minus 6 is 6. 0 minus 8, can I do that? No. Can I borrow from 0? No, but if I put it together, can I borrow from 10? Yes. When I take 1 away from 10, what does it become? 9. And that 9 is just going to go in that first spot, the 1's place right there. All right, and the 1 that I took away is going to go in front of my 0, making a 10. Is that familiar to you guys? Okay, so 10 minus 8 is? 2. And then 9 minus nothing? 9. All right, could I have borrowed from the 1, passed it to the 0, then passed it over? Absolutely. All right. But I do think, especially my advanced classes, learning that trick where you can just borrow from a bunch of zeros at once might be helpful. All right. Questions about that first problem? Subtracting, borrowing? Did we get there? Borrowing can be tricky. Keeping track of all the numbers, especially if you can't read your writing. You ever have trouble with that, reading their own handwriting? Anyone? Admit, thank you, Sheldon. Thank you. Kind of sticking hand it there. All right. Next one. All right, what is special about this multiplication problem? What's something that you're going to have to remember to do? Carry. Okay, you got to remember to carry numbers if they're bigger than just a single digit. What else? Make sure you're in the right spot. When would that be important? When I'm multiplying a 4? So let's go through this because I've seen a lot of people multiply these in different ways. All right, here's what's important, guys. Our goal is to multiply using the algorithm. All right, so an algorithm just means, hey, it's something you can do and it works for every type of problem. Right now we're working with whole numbers, should be review. Next week we'll start doing all of this with decimals. All right, if you can do it with whole numbers, decimals are easy as long as you're using the algorithm. So here's my deal, guys. I know that possibly in past math classes, if you could do it a different way, you were allowed to do it a different way. Maybe some of y'all are like, no, good. Because if I do it this way, that's what I expect on your paper, all right? So we're going to take our 4 and we're going to multiply each number by 4. So 4 times 7 is 28. So write our 8. Like Vinny said, make sure we keep track of what we're carrying. We're going to put that 2 on top. All right, now what? 4 times 1 is? 4 plus the 2. 6. So we write down our 6. Do I need to carry anything this time? No. 4 times 5? 20. So I write down my 0. This time I have to carry a 2 again. 4 times 8? So I write down 32. Plus the 2. Don't forget the 2. So we get 34. Okay, so there's my answer for that. What I would suggest, guys, so you don't use that number again, make sure you mark out those 2's. We're done with them now, right? All right, and then I've finished with my 4, so I like to put a line through that too. All right, so now I'm ready to multiply by 6. Sheldon? We need a placeholder. So 6 is in the tens place, correct? So we need to put one placeholder there. You can put a 0. Some people put just a space. I like to put a 0 so I know there's something there, okay? All right, so 6 times 7? 42. I'm glad y'all remember that one. That one I have to think about sometimes. All right, 6 times 1? 6. Don't forget to add the 4. So we get 10. So that's another 0, but we got to carry the 1 this time. 6 times 5? 30 plus that 1. 31. I'm going to carry that 3. And then 6 times 8? 48 plus 3? 51. All right, let's mark all those numbers out so we don't use them again. And I'm going to mark out my 6. All right, so now the 1 is in the hundreds place. So what do I need to do before I multiply by it? Put 2 zeros. And kind of a good way to tell, if I've marked out 2 numbers, I should have 2 placeholders here. Okay? 1 times 7? 7. 1 times 1? 1 times 5? 1 times 8? All right, now what am I going to do with all that? Add it up. Guys, do you see how I put space in between everything? Did it make this line up easier since there was space in the numbers up here? Right. All right, so when we add it up, 8, 0, and 0. 8. 6, 2, and 0. 0, 0, and 7. 4, 1, and 1. 3, 1, and 5. And 5 and 8. Okay, so I got a really big number of 1,396,788. And I'm just going to put my box around there. Placeholders. Y'all did really awesome. I am really, really proud of how placeholders. You got to use them. That's awesome. All right. If you are not super comfortable with multiplying this way, I think most of us are there now. All right. This is what you've done for the past 2 years, correct? Y'all didn't do that funky stuff. I'm sure your parents complained possibly in like 3rd grade when you had to do the funky multiplying. Some of y'all are like nodding like you know exactly what I'm talking about. Some of us might just be like, that's the only thing I know. I'm good with that. Leah? Yes! I finally watched that last year, the new Incredibles movie where he was complaining like, math is just math. Why can't anyways? Okay. Yes, exactly, Leah. Very good reference. I like it. All right. Okay, so we're going to look at our homework. I'm going to kind of put it up here real quick before I pass it out, because once I pass it out, y'all are going to start working and not listen to me. Pretty much? Probably? Okay. All right. So on our math homework, all right, there are 6 problems. What do you notice there is underneath each problem? There's a lot of space. What do I want in that space? Your work. So guys, I don't want you to just start like trying to do this in your head with the 5 and the 3. I want you to actually line them up, show me that they're lined up and what you're adding together. All right? On the word problem, here's going to be our rule for like homework and tests. If the problem has words, your answer should have words. All right? So just get your answer right. Like it's a sentence that has to be long. So let's see. The question says, how long did Mark spend on homework? Here's my sentence. Mark spent 3 hours on homework. Hopefully not, okay? But, all right, Mark spent 10 minutes on homework. Probably didn't get them all right if you only spent 10 minutes, okay? But I want just a real short sentence. If it has words, write words. Y'all okay with that? All right, I'm going to pass out your homework. I'm going to stop my video.